NASA has just released a stunning new set of images of 3I, Atlas, and they are unlike anything astronomers thought they would see at this stage of its journey. Until now, the interstellar visitor had already proven itself unpredictable, but this latest update has taken the mystery to an entirely new level. What the images reveal is something that bends the definitions of both comets and asteroids. The object is breaking apart shedding large fragments from its surface, yet somehow maintaining perfect stability. This shouldn't be possible. Not for a natural body. Not for anything drifting freely through the solar system. The newest frames, captured by high-resolution telescopes in Chile, Hawaii, and Spain, along with narrowband cameras aboard Earth-orbiting spacecraft, show fragments peeling away in glowing arcs. These pieces drift outward as vast, shimmering streams of material that extend millions of kilometers behind the object. Each fragment glows faintly as sunlight hits it, forming delicate trails that look almost sculpted. And yet, through all this chaos, 3I, ATLAS continues along its path without a single deviation. Its trajectory is steady. Its velocity is precise. Its motion is smooth. A naturally fragmenting body should wobble, spin erratically, or shift course as mass is lost. But here, the fragmentation looks almost controlled. This is where the images become even more extraordinary. Beside the drifting fragments are luminous jets bright, thin beams erupting from the main body of 3I, Atlas. Comets do produce jets when solar heat vaporizes their ices, but the jets seen in these images are nothing like that familiar phenomenon. They are organized. They are symmetrical. And most puzzling of all, they are directed in ways that have nothing to do with the Sun. Some extend sideways into space, others angle sharply away from the direction of travel, and a few even point inward toward regions where no sunlight could reach. Natural jets bend, twist, and flare unpredictably. These, however, remain straight coherent and structurally intact over mind-boggling distances, tens of thousands, and in some cases, hundreds of thousands of kilometers. It is as if the object is generating focused streams of material using a method or mechanism that astronomers cannot explain. The deeper researchers look, the stranger things become. The brightness of 3I, ATLAS continues to pulse in a rhythmic pattern. Observatories logging its luminosity have noticed a steady rise and fall occurring in repeating intervals, almost like a heartbeat echoing across space. Part of this rhythm can be explained by the object's rotation rate, about one full spin every 16 hours, but not all of it. Because here comes another anomaly. Some of the jets do not rotate with the object. They stay locked in the same orientation, as if anchored to an invisible axis. While the main body turns, these beams remain fixed, unmoving, as though they originate from something stable inside the object rather than from its surface. This is unprecedented. Nothing in cometary science can account for a jet that refuses to rotate with the nucleus. And then there is the spectral data. NASA, ESA, and several university observatories analyzed the reflected light from the object, splitting it into wavelengths to determine what materials are present. As expected, the signature of water ice shows up. So do carbon-rich compounds and organic molecules common in comets. But layered within those familiar patterns are rare chemical fingerprints elements and compounds almost never detected in solar system bodies. Some of these materials form only under extremely high temperatures. Others require pressures far beyond anything typical of comets. Still others suggest an environment rich in exotic elements that are scarce around our Sun but may be common around stars of other types. The conclusion forming among planetary scientists is startling. 3I, ATLAS likely formed in a completely different kind of star system one with chemistry, temperature cycles, and physical conditions unlike anything found in our cosmic neighborhood. Every new reading reinforces the idea that this object is not just an interstellar visitor, but a deep, ancient record of a world humanity has never seen. A world with different laws of formation, different building blocks, different history. And whatever happened in that distant system shaped this object into something that does not behave like any comet we've encountered. As the data pours in, each discovery raises new questions. What is powering the stable jets? Why do some remain fixed while others rotate? How can a body break apart so violently while maintaining an unshaken trajectory? And perhaps the most haunting question of all, is 3I, ATLAS simply a natural anomaly from a distant star? Some of the clearest and most revealing clues now come from an unexpected vantage point: Mars' orbit. The planet's orbiters, equipped with high-precision optical systems, have captured a sideways perspective of 3I, ATLAS that Earth-based telescopes simply cannot achieve. This angled viewpoint exposes layers of structure hidden within the object's silhouette, details that were previously washed out by glare or lost in two-dimensional compression. What scientists are seeing from this new angle is both mesmerizing and deeply puzzling. The jets, already strange from Earth, look even more elaborate from Mars. They rise from the object's surface like a network of interlocking plumes, each one threading between fragments that should be drifting apart freely. Instead of dispersing randomly, these fragments maintain a kind of synchronized order, as though connected by invisible lines of force. Under ordinary cometary physics, such coordination should be impossible. Dust and ice fragments should separate, scatter, and fade. Yet 3I, ATLAS behaves with an unnerving cohesion, as if the pieces are aware of each other's motion. The fragments themselves are another enigma. Each one glows with a halo of reflected light, pulsing softly as it tumbles. And despite drifting outward, many of them retain precise alignments with the jets and with each other. Scientists comparing the Mars imagery to the Earth-based frames have noticed something extraordinary. The object's geometry, its shape, its jets, its fragments, appears to maintain consistent angles over long time spans. Such stability has never been documented in any natural object undergoing this level of fragmentation. The main body only deepens the mystery. Instead of the rounded, potato-shaped or stretched profiles typical of comets, 3I, ATLAS has an irregular but distinctly cylindrical shape. Ridges rise from its surface like the edges of a fractured column, and thin protrusions extend from it at angles that defy the natural erosion patterns seen in icy bodies. This form is so unusual that existing models struggle to simulate its rotation or how sunlight interacts with its surface. When hid by certain wavelengths, some regions flash with a much higher intensity than expected. These reflective patches cause sudden spikes in brightness, spikes that further complicate attempts to measure its size, spin, or thermal behavior. Months of close observation have led to one indisputable conclusion: nothing about 3I, ATLAS fits the existing categories. The jets, the fragments, the chemistry, the geometry, every feature breaks the rules set by decades of cometary science. It's not merely unique, it is unprecedented. And yet, behind the confusion lies something far more profound. This object carries the chemical signatures of a star system far beyond our own. The rare compounds detected in its spectra point to conditions unlike anything in our solar neighborhood. Each fragment drifting from its surface might contain atoms forged billions of years ago in the heart of a star humanity will never see. Every reflective ridge and every jet of material could be a fossilized record of processes that shaped worlds orbiting another sun. 3I, Atlas is more than a visitor, it is a relic. A traveler from an alien nursery, carrying clues about the birth of planets and the chemistry of distant stars. And for a brief moment in cosmic time, it is passing close enough for us to study in unprecedented detail. As it continues its slow descent into the inner solar system, astronomers are preparing for the next wave of images and measurements. More data from Mars. More spectroscopic scans from Earth orbiting observatories. More attempts to map its strange interior behavior. Each new observation has the potential to overturn another assumption about how interstellar objects behave. And every update brings scientists closer to answering the question that now overshadows all others. Is 3I, Atlas simply a natural formation unlike anything we've seen, or is it evidence of physics, or processes, far more complex? For now, all we can do is watch. This silent traveler glides through our cosmic neighborhood like a ghost from another era, telling its story one fragment at a time. Every pulse of light, every shifting jet, every oddly aligned shard is a message from a place beyond our imagination. It reminds us that the universe is not predictable, not tame, and not fully understood. Out there, between the stars, the unknown is always waiting, and sometimes, it steps directly into our path, daring us to look closer. 3I, Atlas is doing exactly that, and humanity is watching with awe, with confusion, and with a growing sense that the universe has far stranger things in store than we ever believed.